In this lesson, we're going to take a look at perpendicular bisectors. Remember that the word perpendicular just means that we have that right angle, and then bisector means we're cutting that segment into two equal pieces. And so it may or may not go through the vertex of the opposite angle. But here are our two examples, kind of one going one direction and then the other one is the converse. So if we know that it is a perpendicular bisector, so perpendicular, and then we have our tick mark showing it's a bisector, then we know that these segments here, AC and CB, are going to be equal to each other. So the converse is just knowing that if those segments are equal to each other, then it is a perpendicular bisector. So down here, TR is the perpendicular bisector, so that would mean that segment QT is congruent to segment ST. And so we can go ahead and set each of those equal to each other and solve for x in order to find QT. And so x is equal to 4, and so we're going to plug 4 back in, and then we can get our QT, 7 times 4 minus 3. So 28 minus 3 is 25. Down here, to find CD, it is going to be the same as BC. If these are congruent, then this is a perpendicular bisector, which means if that's 4, then this side would have to be 4. And then to find AC, we're going to take a look at this kind of as a triangle. So what is this length or leg of this right triangle? If we have the other two, we can use Pythagorean Theorem, a squared plus b squared equals c squared, to solve for this AC. And so we just have to make sure that we use the C as the hypotenuse, the longest side across from our right angle. Doesn't matter which one we choose to be A and B. And then we plug in those values and we square, and then we start solving for A. Once we get to this step, if we get A squared, we still need to do one more step because we want just A. So we're going to square root. And so A is going to be equal to the square root of 153, which is approximately 12.4. So that's A, or when it's leg A, is really AC. BC is going to be the same as this side, which is 8.5, so this side would be 8.5. This segment over here, if these are congruent, then these are congruent. So if that's 6, then XY is 6. And again, if we have the perpendicular bisector, then these segments would be congruent. So we're going to set a 3x plus 1 equal to a 5x minus 3 and solve. So x is 2, but we want to find PQ. So we're going to plug that back in. The 2 for x, and 3 times 2 is 6, plus 1 is 7. When 3 or more lines intersect at a common point, that point is called the point of concurrency, or concurrent lines. So there's our point of concurrency, and then concurrent lines. So when we have 3 sides of a triangle, and we have our perpendicular bisector on each side, then those points, the point that they are concurrent at, is called the circumcenter. So perpendicular bisector the point of intersection forms the circumcenter. So I want you to think of circumference, because through all these vertex points, if I had a circle, the center of that circle would be the circumcenter. And the circumcenter is not always in the inside. It depends on what kind of triangle it is. It could be in the interior, could be in the exterior, or could be on the side or on the triangle. So notice that acute is in, obtuse is out, and right is on. But they are all going to be equidistant from the vertices, our point that is the circumcenter. So here's one with our circles drawn: acute in, obtuse out, and right on for our circumcenter. So what if I had this triangular shaped garden? Can the fountain be placed inside of this triangle? Well, we need to know what kind of triangle it is. So this angle right here is not right. It's not acute. It would be obtuse, right? So if it's an obtuse, it would have to be outside of the triangle for my circumcenter. So no, the triangle is obtuse. So the circumcenter would be outside. The triangle. All right, so this next one, we're going to figure out what FL is. So what is FL's length? Well, we know it looks like this part of the triangle, this leg. Do we know this hypotenuse here? Well, technically, any point from each of the vertex points into this circumcenter is going to be the same distance. So if this one is 4.85, then this one is 4.85, and this one would be 4.85. But really, we just need that pink one right there. So now I have two sides of my right triangle. I can go ahead and find the third. Remember, our formula is a squared plus b squared equals c squared. And notice our c, we do have it. It's across from the right angle. We're going to make sure that our 4.85 gets put in for c. And then 2.28 in for a or b, doesn't matter which one. And one way that you can type this into your calculator, instead of squaring each of these and then doing your subtraction, you can type it all in at once. But if that's too much for you, please don't try and do that. But I can show you on the calculator how we would do that. We're not actually taking this minus this and then squaring it. We're taking this squared, so the squaring has to happen first, and then subtracting this squared. But your calculator will do it for you if you type it in correctly. So let's take a look at how we would do that. So 4.85 squared minus 2.28 squared, enter. And notice we get our 18.32, and that is a squared. It's not a, so we again have one more step that we need to do, and that is to take the square root. And so I'm going to do the square root. Sometimes we have to hit the second button, just depends on your calculator. Square root of 18.3241. And that is our A, 4.28. Or 4.3, depending upon what you're rounding to. It looks like these are all hundredths, so we'll leave that one as hundredths. And there we go. We know that this is 4.28. And this one would also be 4.28. Remember that that's being bisected. So if we work our way around this kind of circumcenter here, we know that this one is going to have to be congruent to this one's congruent to this one, and these are congruent down here. And then we have all of our points. So our friends meeting for coffee, they're going to meet equal distant. So all three of these vertex points are equal distant from our circumcenter. So this one, and this one, and that one are going to all be congruent to each other. So for our VW, it's going to be congruent to XW. Our AZ is going to be congruent here to our AV. Oop, lost my little tick mark there. And then XY is going to be congruent over here to ZY. And then we again have all three of our kind of vertex points to our circumcenter being congruent. So that would be XU, VU, and then this one right here, ZU.